Hi, welcome to Avocet Math. In this video, we're going to look at another problem from our set of AMC12 counting problems. So let's see what we have. How many even three-digit integers have the property that their digits read left to right are in strictly increasing order? So this is a bit similar to the previous problem where we were forming monograms in alphabetical order. We're just trying to do a similar problem with numbers. But this problem is a little more complicated in that we're constraining our treatment to even three-digit integers. So just for the moment, let's relax this condition and just consider all three-digit integers with digits in strictly increasing order to just get a feel for how this might work. So in the case where we're dealing with all three-digit integers, we're basically selecting a combination of three distinct digits from the set 1 through 9 in order to form a set of three digits that can be arranged in increasing order. Now we don't consider the number 0 because any selection that includes the number 0 will always have the 0 forced to the leftmost digit, and we don't count three-digit integers with a leading 0. So 0 can be excluded from our count. So as we saw before, any combination of three distinct integers from the set 1 through 9 will form a set that can be rearranged in increasing order, so the total number of integers amounts to a combinatorics problem where we're choosing three distinct items from a set of 9 distinct items, and that can be done in 9 times 8 times 7 divided by 1 times 2 times 3 ways. And that works out to 3 times 4 times 7 for a total of 84. Now this is not quite the number we're looking for, but it serves as a useful upper bound for the problem that we're actually going to try to solve. So let's try to incorporate this condition where we're dealing with even three-digit integers. Now there really is no way that I can see to incorporate that condition in sort of a single unified way, so it appears as though we're going to have to do some casework. So let's consider the various cases of the units digit, and we can basically break this down into just a few cases now. And the first case to consider is where the units digit is 8, which then forces the two digits to the left to be chosen from the set 1 through 7. Also, the units digit could be 6, which then forces the two digits to the left to be chosen from the set 1 through 5. Likewise, 4 forces the two digits to the left to be chosen from the set 1 through 3. And we notice that if we choose the units digit to be 2, there really is no way to choose the leftmost digits in any consistent way. So now we only have 3 cases to consider, and we have to basically tabulate now the total number of digits with the units digit of 8, 6, and 4. So in the case of 8, we now have to select two digits from the set of 1 through 7 in a similar way that we did here in order to form the total number of three-digit integers that end in 8. And the number of ways that we can do that is to choose 2 to form the two digits from the set 1 through 7, and that can be done in 7 times 6 divided by 2, which is equal to 21 ways. And likewise, for the case where the unit digit is 6, we have to select two digits from the set 1 through 5, and that can be done in C5 two ways, which is 5 times 4 divided by 2, which is equal to 10. And finally, we have to choose two digits from the set 1 through 3 to arrange in increasing order, and that can be done in C3 two ways, which is 3 divided by 1, which is equal to 3. And now we just have to tabulate up these 3 cases. 21 plus 10 plus 3 is 34 for the final answer B, 34. Anyway, it's an interesting problem. It's a bit tricky, but this type of logic comes up in other problems, and it's something that's worth understanding. So hope that helped. Bye-bye.